Good morning. I would like to talk with you about bias in AI because this is something that is very important for me because I have an inherent dev and sometimes I expect some bias, especially when I use a speech recognition system. And when you use speech recognition system, you have a language model, and this language model is impacted by all the bias we put in the literature, in every document we put. And sometimes what is very interesting is that you have gender bias in the way that the speech recognition system is generating the text. Why AI? I want to talk about that. 98% of the companies, of the business companies, want to deploy AI. That's a good news. But only 30% of CEOs, C-level executives, don't trust AI. So one of the reasons why they don't trust AI is that they fear the compliance system that you may have with AI. The compliance can be, okay, you don't have to discriminate people between male and female. You don't have to discriminate people based on their disabilities. And this is why we have to monitor the bias we can put over gender, over race, over disability features of people in AI. So bias in AI is not new. This kind of bias has been studied since more than 6 years ago. But in the paper, at the very beginning, we were understanding where we can put human bias in the system. And then we start to measure them by taking what we call the privileged feature and the unprivileged feature. If you look at this room, there is a privileged feature which is a male room. And you have an unprivileged feature which is a female room. And we start to measure what is the outcome of an algorithm for male and female. And sometimes the outcome can be very different. And now, once we have the means to measure, we start to develop all the means to act on this bias. And that's why IBM Research, since now 3 weeks ago, have put all the algorithms that to measure and to act on this bias, open sources on the internet. So you can go on these 2 websites that explain a full methodology to measure and to act on this bias. So I will explain you the methodology you have to put in all AI algorithms in order to measure that. The first step is to analyze your data set and to select the feature on where we want to measure bias on. It can be female, male, female, gender. It can be the location of the people. It can be the ethnicity. It can be a lot of bias system where we don't want the system to act over. And sometimes it's very more difficult than that because even if you don't use the gender feature in your algorithm, as now the power of a model you build and you can build with several hundred of features sometimes, you can deduce this feature from the other features rather than the gender one. So the model can act with a bias between male and female because of the other features you have in your data set. So the first step, once you have the data set, is to measure what is the impact of the data set against this bias on gender, for example. So we have implemented a lot of metrics that are coming that are in the paper, of course, but they are all open sources in Python. And I show you here 5 more important metrics. The first one is the statistical parity. Is that you take the privileged feature, the unprivileged feature, and you balance what is the rate of the favorable outcome on each way. The second one is to use the true positive rate and the false positive rate, and etc. So you have several means and more than 30 means to measure the bias. And so it's important to use several way to measure that, because if you choose only one metrics, is that you can see that there is no bias and there is one. For example, here, the three first metrics show that there is no bias, but only the tail index can show you that there is a bias. So for the second measure, which is the edge, for example, you don't want a policy claims to be positive or negative based on the edge of who makes the claim. So you can have a disparate impact, for example, the fourth, a metric that contains a bias. So once you have understood what is if there is a bias in your data set, the second step is to take a mitigation action. And so far, we have implemented 9 mitigation actions that are in the paper. And now you can find again also on the GitHub of this AI Fairness 3060 Toolkit. The first one is to act on the training data. What you can do is to reweight the training data based on what is privileged feature, what is unprivileged feature. The second one is to learn a probabilistic transformer between the privileged and the second one. And sometimes, what it can be very good is to gather more training data. For example, if you do a visual recognition system, you can have people with wheelchair. And as you know, often visual recognition systems are convolutional and take all the features, the probabilistic rate of detecting the wheelchair can be very different from detecting a car, because there is some wheel. So this is a bias also in visual recognition systems. So what you have to do is to gather more training data in the visual recognition system to have people with wheelchair inside. It's very important for that. Then, if you cannot act on the training data, you can act on the classification. So to add classification time, to learn a classifier that maximizes the prediction accuracy and reduce an adversarial ability to determine the protected attribute from the prediction. So that you can act directly in the model. Second, and the last step, if the two first steps didn't work, is to work on the prediction level. If, for example, the policy prediction says that for a male is 76% and for female is 70%, then you boost the female rate. So this is a free way to mitigate the bias, a free-way algorithm to mitigate the bias, and you can have 5 other ways in the website. And finally, you have to compare the accuracy of the model, because the accuracy of your model, as you have put a bias correction system, can change before and after the bias. And what is really interesting is that all that mitigation actions can reduce the bias in your model without modifying a lot the accuracy. And sometimes in some implementation of that I have done, the accuracy can be even better after reducing the bias. All this code can be implemented by all of you. But for companies that don't want to implement research code like that, we have released AI OpenScale that embed all that bias mitigation and all that bias detection algorithm in a single control tower of all AI algorithms. And this control tower can act on whatever the technology of AI you use, whatever the hosting of AI is. And this system, AI OpenScale, can monitor 4 main things: the accuracy over time of your model, the performance, the lineage, to have the traceability of the model, what kind of data set you have used, what kind of model, etc., in order to have a compliance and to say if someone asks you, hey, I have a prediction today, it was false, what did you use in order to do this prediction? So you can trace down what is the data set, what is the model, etc. And finally, is embedding all the algorithms we have seen before, especially the fairness. But just as I've said before, it's very difficult to monitor some bias, like the disability status, because you don't have the right to monitor that on your data. So my point of view on what I feel is that the best asset to protect against bias is to have an inclusive team. And the team who is implementing all the AI in France have a lot of diversity and included people with a disability like me in order to think about bias every day when they implement AI. For example, like no more than 5 days ago, we have implemented a simple virtual assistant that works for an HR system. And the first thing I have done is to test all the questions I have as a deaf people. So that this is our best asset to test against bias that you cannot monitor. So my objective here was to present you that it's really important to monitor the fairness of your algorithm, that you can have code, implemented code and implemented algorithm that you can use right now in order to monitor your data set, to mitigate the bias action in your model in order to have a better AI for everybody. Thank you.